We'll proceed in vector and commercial calculus, vector and energy calculus, vector and commercial calculus, vector and energy calculus. The topic we are pursuing, it is not available anywhere else. The energy model of vector, energy model of algebraic vector, and energy model of vector, energy model of algebraic vector, energy model of algebraic calculus in vector. So, energy model, we are also renaming it as commercial algebra, commercial calculus, commercial algebraic vector calculus. So, in that sense, what we have seen till now, we have seen that if a energy source, there is an energy source. If there is an energy source, then there will be force field around the energy source. Okay, if any item comes in the force field of energy source, it will get attracted toward the energy source. Can you give me one better example of energy source? Okay, everything is energy source what we see in celestial body, but very big example is a black hole. If you see galaxy, any galaxy, then black hole is considered as high power energy source. Even light cannot pass through the black hole. It will attract the light also. That much energy a black hole contains. Why black hole needs that much energy? Black hole need that much energy because full full galaxy it has to carry the energy of black hole. On that only full black hole is carried. Look, full black hole is sustaining in the energy of sun for solar system. People know about solar system how much? Only 9 planet people know, and few asteroid they know between the Mars and Jupiter, and then they know another Kuiper belt that is between that is around that is after Neptune. There is a Kuiper belt. There meteorites, meteor, and these are there. Okay, so kind of asteroid, meteorite, comet. So they live in that region. That much only people know about solar system. There are many things in solar system, but anyway, solar system itself is a kind of enigma. Solar system itself is a kind of suspense. How big it is and what are there in the solar system. But sun is it is considered that Jupiter makes solar system in two parts. One is inner solar system and one is outer solar system. Jupiter makes solar system in two parts because Jupiter is the largest among all the planets and Jupiter is a gas planet similar to Sun. But Jupiter is again 10 times lesser to Sun as far as radius is concerned. Means 10, 10, 10. 1000 less volume of the Sun is Jupiter. That much small it is. Sun is 1 million, 10 lakhs time bigger than Earth. Sun is 10 lakhs time, 1 million time bigger than Earth. That's how Sun carries full solar system along with it. Now just consider that there are billions of stars in the galaxy, in Milky Way galaxy. There are billions of stars. One of them is Sun, that is from two-third kilometer from the two-third of the distance. If it is a Milky Way is a kind of circle, then two-third of the radius of the circle where the solar system is. Billions of stars are there, and in one star, Sun, see the how much it is like a enigma. It is a different kind of world. Okay. Now think that how much. Now, if we see solar system, then all the planets, celestial solar system, then Sun carries 99% of the weight. 99 or 98% of the weight of the solar system comprised in Sun only, and then other in Earth is so heavy. Just think it is all are in 1 or 2% of the Sun only. That's why Sun carry everything together when Sun revolves around the kind of black hole. Just think that how much energy black hole consists. It needs that much energy because full galaxy, it has to carry full galaxy along with it. So in that sense, the energy, if I have energy source, it has a force field all around. If I have an energy source, it has force field all around. If it has force field all around, then anything comes in its force field, it will get attracted toward the energy. So this is what we talk. So there are two things we saw in the energy source. One energy source is path independent. If Earth here, Earth is not top, Earth is down. If Earth is down, if I leave an item like this, it falls, then Earth is working. Earth is losing energy. That's why item is moving. If anything is moving, then someone is losing energy. Okay, I'm tired now because I lost energy making it move. Similarly, if I drop like this, if it is moving like this, Earth is losing energy because Earth is working for it. Path independence means the net energy lost by Earth when item is moving from one point to another point is dependent only on the begin point and end point, not on the path. It is a straight line. If I make it revolve like this or make it go by a staircase, doesn't matter. Earth loses same energy, depend upon begin point and end point. If I make anything revolve in a loop, in a closed loop from here and then back to here, Earth won't lose any energy because begin point and end point are same, but it should move. That is the idea. Like here, it is moving. If I keep it on a staircase, it will move. It should move automatically. If it moves automatically in Earth gravitational force in a closed loop, then Earth is not working. Okay, because it depends upon the begin point and end point, and begin point and end point are same. Okay, but if it is path dependent, then energy calculation will be different if path is different. Even though begin point and end point are same, if it is a straight line, it is a circular line, any line, everywhere energy computation will be different. That is path dependent. Now we are in calculation of kind of nature of path dependent. What is the nature of path dependent? Then we understood the nature of path dependency depends upon two things. First thing is if there is an energy source, in energy source item is moving in a closed loop, same point, one point and coming back to the same point. How much is the energy that computed that kind of wasted from the energy source? Or wasted, VES, wasted from the energy source. Divide it by the area. If line is big, then energy that is gone from the energy source. Okay, the energy that is gone from the energy source is kind of, okay, I believe there is a problem on my mobile. I'm thinking something. Okay, so the energy lost from the, if something is moving in a bigger, if something is moving in a bigger radius, something is moving in a closed loop in bigger line, then energy computation will be more if it is path dependent. If you divide by the area, it is normalized. Okay, this is called circulation density or nature of the energy source. How much energy is invested with item is moving in a closed loop. Divide it by the area. That is same thing. That is exactly same thing. If energy source is a force, energy source has a force field, and then see the gradient of force, the differentiation or change in the force with the x and y. If capital F is the force, consider this is energy source. Then what is force? Typically force will be radial. If this is energy source, if this is energy source, then typically force will be towards it. This is called radial. Okay, whatever it is. If this is the force, then force has two components, F1 along x-axis and F2 along y-axis. F1, F2. Now, if F1 is changing along y, then it is called dF1 by dy. That is not zero. If F1 is here different, F1 is here different, F1 is here different. This is x-axis, this is y-axis. If this is F2 and F2 is changing when I go along x-axis, then dF2 by dx is there. Df2 by dx minus df1 by dy, that is also called curling factor. Because if I take a line like this, if I take a line like this, if I take a line like this, then df1 by dy will not push it, rather it will make a torque like this. Because force, here force is different, here force is different. It will make a torque like this. Similarly, F2 is different at different point, it will make a torque like this. If df2 by dx minus df1 by dy is 0, then there is no torque on this. It will move here and there, but there won't be any torque on this as such. If it is moving in a closed loop, this item is moving in a closed loop, then it will be like this only in a closed loop. But if df2 by dx is not same as df1 by dy, then it will start moving like this, because the force field has f1 and f2. F1 is changing along y-axis, f2 is changing along x-axis. So F2 is changing along x-axis. If this is the item that is moving, it will make a torque on the item. If F1 is changing along y-axis, then it will make torque on the item. Net torque will be dF2 by dx minus dF1 by dy in anti-clock direction. If I see clockwise direction, then dF1 by dy minus dF2 by dx. So in anti-clock direction, dF2 by dx minus dF1 by dy, that is the torque that is imparted on this item. If torque is 0, then it is path independent. How much is the torque? That is the nature of path dependency. Both are same. Circulation density, energy computation in a closed loop divided by the area, and the df2 by dx minus df1 by dy along k direction. Df2 by dx minus df1 by dy means we are calculating for the force that is in 2D in xy plane. Then the curl factor torque, if it is rotating in xy plane, torque will be exactly perpendicular. If this is x and this is y, if it is rotating in xy plane, then torque, it makes a surface. Consider this is the surface it is making. If it is rotating like this, it will make a surface. Direction of the surface will be perpendicular to the surface. This is the direction of the surface. Because if I rotate it like this, then it will rotate like that. Okay, that is the direction of the torque curl. So generally people say, what is the curl factor of a force field? Can you calculate? That is actually we are trying to calculate the path dependency nature of the energy source. If earth is energy source, how much is the path dependency nature of the energy source? That is df2 by dx minus df1 by dy. That is the net torque tendency. If anything fall, if any item is fall on earth, there is no torque, it falls straight. Otherwise, if there is a curling factor means path dependency. If there is path dependency, it will start rotating like this while falling. Then earth is not path independent, path dependent. More curl factor is there, more df2 by dx minus df1 by dy is there, more path dependency is there in the energy source. Okay, because force field, it represents the energy source. Similarly, if energy in a closed loop divided by the area is more, then path dependency is more. Now we are making some calculation now. Consider there is a force field that is along a circle. There is a force field that is along a circle. This is a circle, this is xy plane, this is x-axis, this is y-axis. This is xy plane and force field is along the circle. What is the path dependency nature of the energy source? This force is not radial the way we think. If this is energy source, typically force field be along the energy source. But there is some energy source for which force field is along the radius of the circle. Amazing. Okay, then what is the curl factor? Last video we calculated. Someone would say, what is the curl factor of the force? Or what is the path dependency factor of the energy source? Or what is the tendency of the force that is generated by the energy source to rotate something? All are same. Torque generating tendency of force field or path dependency extent of the energy source, all are same. So as per the calculation, we have to calculate the energy computed in the closed loop. If it is a circle and force is along the path only, then force into dot product will be 1 because theta is 0. So force into displacement divided by the area. Displacement is 2 pi. Now the question is the amount of the force. Power of the force is 2 into radius. If radius is r, then power of the force is 2r. Okay, then force into the displacement is 2 pi r into force 2r. 2 pi r into 2r. 4 pi r square divided by the area pi r square gone. 4 is the net torquing tendency, curl tendency of vector field. Can you please prove it through curl fundamental df2 by dx minus df1 by dy? Now we are proceeding. Okay, it took some time. Now we are proceeding. If that is the case, then now what is the equation of the force? It will be algebraic force because it is not a straight line. It is changing everywhere. If this is the radius, consider any point here x comma y. If from center, if I connect this point, then it will be a position vector that is xi plus yj. Any point, any line connect origin. It is centered at the origin. Any point connect origin and any point x comma y. This will be called xi plus yj. That is the position vector. Connecting two points, if I say vector, one point minus another point, x minus 0, y minus 0. It is a position vector is xi plus yj. If position vector is xi plus yj, and I know that force vector is tangent at every point. So this force vector is perpendicular to this line. If I say any line like this, any position vector like this, we are trying to find algebraic equation of force vector. This is what we are doing. If this is force vector, then perpendicular to the force vector is the position vector. And position vector is xi plus yj. If they are perpendicular to each other, then it will be yi minus xj. Because dot product will be 0 because they are perpendicular. If position vector is xi plus yj and force field is perpendicular to it, then it will be y minus xj. Now you do the dot product, it will become xy minus xy, 0. So equation of force field is, for this explanation you will not get in any of the book. Okay, typically people will say 2r is the force magnitude and direction is same along the line into 2 pi r. This explanation will not give calculating that through the Cartesian coordinate. If this is the force at tangent along the line, then force equation is perpendicular to this line. Okay, please watch our previous video. Many times we have proved it that how it will be perpendicular to each other. Now, if that is the case, then xi plus yj is the position vector, and then force will be yi minus xj. The dot product will be 0. In that sense, I have force field whose equation is yi minus xj. Yi minus xj. Then magnitude of this force field is x square plus y square square root. Okay, if I talk about the magnitude, if it is of length 1, then magnitude will be x square plus y square square root. If it is x comma y, if magnitude is 1, then it will be x square plus y square square root. If it is of radius a, if its radius is r, if I would rephrase, this is a circle whose radius is r. So this point is x comma y. If this radius is nothing but this length is x square plus y square square root. Okay, so if I have a force vector that is yi minus xj, then its magnitude is x square plus y square square root. That is same as the radius, but the magnitude of force we have taken is twice of the radius. So the force field is 2yi minus 2xj. Makes sense? If this is force field, the curl vector will be df2 by dx minus df1 by dy. df2 by dx. df2 is minus 2x. Then it will become 2. df1 by dy is is 2y. It will become 2 minus 2 minus 2 minus 4 4. Okay, so curling factor is 4. Same thing, right? What we calculated curling factor, same thing here. Curling factor is 4. Okay, now let's calculate the curling factor through the energy calculation only. In energy, I have to calculate energy in a closed loop, divide by the area through calculus. So through calculus, energy calculation is force vector. This much is not there in any of the book. So repeatedly I am saying, if someone is curious about the negative sign energy calculation, then he can take the vector. I took vector as yi minus xj. Someone can take minus yi plus xj. Same thing, it will come as 0. If I say minus yi plus xj, minus yi plus xj, when y is 0, then it will be xj. Then it will be, that is correct. Okay, this will be in this direction. That is correct. Minus yi plus xj in anti-clockwise direction. That is better. Minus yi plus xj. Now it will come as 4. Anyway, now we want to calculate the energy calculation in a closed loop through the energy calculation we did. That is force vector dot d of position vector. D of position vector. Force vector dot displacement vector. Displacement vector and force vector, they are algebraic here. Better go with the integral calculus. Force vector dot d of position vector. So position vector is xi plus yj. Force vector is f1i plus f2j. It becomes f1 dx plus f2 dy. f1 dx plus f2 dy. f1 is minus y and f2 is x minus y dx plus x dy. Okay, if it is circle, then y equal to square root of a square minus x square minus a square root of a square minus x square dx plus x d of square root of a square minus x square. It will come as minus x divided by square root of a square minus x square dx. Make sense? So here it is minus square root of a square minus x square dx. There it is minus x square minus square root of a square minus x square minus y dx minus x square by square root of a square minus x square dx. If I settle it down, minus minus I can take it out. Okay, now it will become a square minus x square plus x square divided by square root of a square minus x square. X gone. Now it becomes a square. It becomes a square. A square by a square root of a square minus x square. That is the energy calculation. Okay, if that is the case, then how much it will be? Now outside we have kept minus. Now outside I'll keep a square also. Now 1 by a square root of a square minus x square dx. Integration is sine inverse x by a. I believe 1 by square root of a square minus x square dx. Integration will be sine inverse x by a. Now limit, when we are talking about the limit of the x is minus a to a. Where x is minus a to a. Okay, if that is the case, then it will be sine inverse x by a. I keep x as a, sine inverse 1 pi by 2 minus sine inverse minus a by a, sine inverse minus 1 minus pi by 2 minus minus plus pi a square, pi a square. That is the kind of we get the value pi a square. Okay, pi a square, and then we calculated for the top half only because we took Cartesian coordinate system. It is centered at the origin. If it is centered at the origin, then we got pi a square twice 2 pi a square. 2 pi a square divided by the area, that is pi a square 2. Okay, 2 we are missing somewhere. Then it will come as 4. Okay, so where we are missing? So force field we took minus yi plus xj. Okay, force field minus yi plus xj. This is what force field we took in this direction. There, I believe we have to consider force field as twice of the radius, something like that. Then it will come as 4 only. Or if someone is very kind of curious, then he can use polar coordinate system in calculation of this. That is f1 dx plus f2 dy. Consider x equal to r cos theta and y equal to r sin theta. R is the fixed radius because it is rotating around the radius. So a cos theta, a sin theta. Force field, we have to work on this. Force field, we have to work on this. I believe we took force field there as 2x. So here also I have to take 2x to force field F1. F1 is minus 2y. That's why it is coming half. Minus 2y. If you remember well, force field we have to take like that because it is twice of the radius. Okay. So if I take force field as y minus yi plus xj, then the amount of the force is x squared plus y squared square root. That is the radius. When it is twice of the radius. So minus yi minus 2yi plus 2xj is the force field. I'll repeat the question again. Question is, if there is a force field that is along the path of the displacement, and magnitude of the force is twice the radius. If radius is a, then force magnitude is 2a and direction is along the path. How much is the curl factor of the force field? Energy source through which this force field is there. What is the rotation tendency of the energy, or how much is it path dependent? We are calculating through the algebraic calculus, that is f1 dx plus f2 dy is the net energy calculation. If I force field we calculated earlier, it is minus 2y because twice is the radius, minus 2yi plus 2xj, that is the force field, so that is perpendicular to the position vector. Position vector is xi plus yj, perpendicular will be minus yi plus xj, and this magnitude is x square plus y square square root. That is the radius, twice of the radius. 2 minus 2 minus 2yi plus 2xj. Now net energy calculation in a circle is point A to A, same point to same point, same point to same point. Okay, same point to same point, same point to same point. Okay, so the way we calculated in x dx, it will be from A and back to A and back to A. Otherwise, if we had taken A to A, it was half. That's why we doubled it. Anyway, A back to A. Let's go with the polar coordinate system. If I talk about theta, then theta will go 2 pi. It will be better calculated. 2 pi. So now polar coordinate system, if I say, then force field, that is minus 2yi plus 2xj, that is the force field whose magnitude will be 2 of a square root of x squared plus y squared. That is 2 of radius. So all right now. So now F1 minus 2y dx plus 2x dy, that is the energy computation. Y is a cos theta and y is a cos theta and y is a sin theta and x is a cos theta as per polar coordinate system. So minus y minus a sin theta minus a sin theta 2. Let's keep outside and forget it. Minus 2 what minus 2 minus a sin theta minus a sin theta d of x, that is a cos theta. D of a cos theta is minus a sin theta again. So minus minus plus a square sin square theta. A square sin square theta. On that side it is x 2x d 2. I have taken out x dx. X is a cos theta and x is a cos, that side it is x dy. A cos theta and differentiation of a sin theta. A square cos square theta. A square I can take outside, 2a square is outside. Sin square theta plus cos square theta, gone, 1. Okay, Now differentiation integration of theta. Theta integration 0 to 2 pi because circle 2 pi 2 pi into 2a square 4 pi a square, it is better now, 4 pi a square 4 pi a square divided by pi a square, that is the area. Again it will come as 4 only. So in the book you will generally see it is 2r radius into 2 pi r divided by pi r square. But this is the way actually calculating the kind of torque factor in Cartesian coordinate system, polar coordinate system, and then finally through the kind of through the curling factor, that is df2 by dx minus df1 by dy. Now we will take another example. We will brush it. Calculating the curling factor, we will brush it. Our one example is pending, that is proving Earth's gravitational pull is path independent. Then we will see another example that is considered. There is a there is a there is a kind of circle. Again, there is a circle, and circle is there is a circle, and circle is rotating. Circle is rotating. Circle is rotating at angle omega. Omega is the angular velocity. What is angular velocity? Angular velocity means if this is radius, and this radius from 0 to 2 pi, it went in 1 second. Then the angular velocity is 2 pi. The distance is calculated in angle. 2 pi angle it covered in 1 second. So 2 pi is the, sorry, pi by 2. Pi by 2 is angular velocity. If this item is covering full 2 pi in 10 seconds, then 2 pi by 10 second, 10 second, that much radian per second is the angular velocity. So something is rotating in a circle, some item is rotating in a circle because of some force, or there is a kind of force, there is a force, there is a force, because of force the item is rotating in a circle. So force is rotating in a circle. Same thing example, similar example, whose angular speed is omega and radius of the circle is r. If anything is rotating because of the force, then the linear velocity v equal to angular velocity into radius. What is linear velocity? Linear velocity is how much meter per second he is covering. That is linear velocity. Okay, linear velocity, how much meter per second he is covering. If radius is 1, then if he is making full rotation, then he is covering 2 pi r. R is 1 2 pi. If radius is 10, then he is covering 2 pi into 10 meter. 2 pi into 10 meter, that is the circumference. That much he is traveling. In how many seconds? That is linear velocity v. So it is clear, right? If I have 2 pi as angular velocity, consider 2 pi is the angular velocity, means 2 pi radian, it is moving in 1 second. 2 pi is in 1 second. Then how many meter he is traveling in 1 second? If angle is 2 pi, someone is covering in 1 second, then how much linear length he is covering in 1 second? Depends. If it is very small, if this length is very small, depends upon the radius. If radius is 1, then he is traveling 2 pi meter in 1 second. If radius is 10, then he is covering 2 pi into 10 meter in 1 second. If radius is very big, that much he is covering in 1 second only. But angular velocity is same. He is covering 2 pi angle in 1 second. But if you see the actual the circumference someone is traveling in meter, then that much is to depend upon the radius. So that velocity, if I go bigger circle and he is covering full 2 pi in 1 second, the velocity is very high. So linear velocity is angular velocity into the radius. If I see the vector form, the linear velocity vector in a vector is equal to the angular velocity cross product with the radius. So if this is a circle, then radius is like this. And angular velocity is perpendicular to the surface, because angular velocity means it is rotating like this. If I take a kind of a stick here, stick it here and rotate it like this, it will rotate like this. So the angular velocity direction is perpendicular to the surface. If this is angular velocity, this is radius. If I do cross product of these two, then it will be time in this direction. If this is z, this is x, this is y. Cross product will come in y. So everywhere the linear velocity is tangent at this direction. The question is arising: if something is rotating with the angular velocity omega with radius r, and then what is the curling factor of the force that is along that we consider as the velocity vector? Velocity vector, if I consider that as a force kind of thing, or someone say, what is the curling factor of the velocity, linear velocity? Better term, what is the curling factor of the linear velocity when something is moving with the angular velocity omega in radius r? That is a very big question. Look like very simple, right? Curling factor. Then, but if someone go little bit inside, it will be really very difficult. So this is kind of assignment that people can think what is the curling factor in when something is moving in a circular way at angular speed omega at radius r, and then curling factor of the linear velocity v, where v equal to omega cross product of the r vector. Okay, please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.